Good morning all. Welcome to the last day of faculty development program on machine learning using Python. I hope the entire journey was very fruitful for everyone and everyone learned something or the other throughout the week. Today we are with the last session for this faculty development program by Miss Nidhi Grover. She had already taken our 2 sessions for Python and the steps of machine learning. We are here with another session with her for data visualization for machine learning using Matplot library. Welcome everyone and welcome Nidhi ma'am. Welcome to the last day of the session.
Yes, can you hear me?
With it.
Hello, can you hear me?
Yes ma'am, we can hear you. You're audible.
Thank you. Thank you. Okay. So, shall I start? Can we start
Yes
now?
ma'am, you can start with it.
Thank you so much. A very good morning to one and all, and I welcome you to this session with me. So here in this session, we'll be talking about the last part of analytics. Basically, the ultimate thing is visualization. So we will be talking about data visualization, and that too through coding, hardcode coding via Matplotlib and Seaborn. Okay, so I'm just sharing my screen with you. I hope my screen would be visible to all. Soni ma'am, can you give me a check? My screen is visible?
Yes, it's visible ma'am. It's visible.
Thank you so much. Thank you ma'am. So guys, this session will be about data visualization. So before we start, let us just take a quick overview of what data visualization is, because this is one of the most important part. When we are done with everything, when we have done data preparation, we are done with machine learning algorithm, we have prepared our model, we have implemented our algorithm, and finally we are getting results. Now, in this process, we need to explore our data and we need to present some analysis to the people. Okay, these people, these audience can be your managers. These can be, some data scientists to whom you want to show your analysis, or they can be your team members, or they can be your clients also. Fine. So you need to present your analysis to the audience. That is the main purpose of doing analysis, because you need to present them, you need to fetch out some results, and you need to show those results to the audience. Okay. Now, how you go about data visualization? The visualization of data can be done through hard code also and through tools also. Okay, there are numerous tools available also. So if we are doing hard coding, if we are just coding everything, then in Python we can use the two ultimate libraries, which is Matplotlib and Seaborn. Currently we have one more library which is more specific, and it is used for creating good scientific plots, and that is Bouquet. Okay, so in all we have three libraries which are giving us good results on visualization. These are Matplotlib, Seaborn, Bouquet, and another library we have Plotly. Okay, so we have a variety of libraries available with us in Python through which we can present our analysis and through which we can explore our data also. Today in the practical, I will show you how we can explore our data, how we can do some analysis with visualizing our data. Okay, we'll take a data set and then we'll work with it. So data visualization is a key part of communicating the research to others. Okay, whether it is through histograms or through scatter plots, bar charts, pie charts, box plots, or plots. All these charts can be good visualization techniques that help you to unlock insights from your data. So as I told you, the ultimate aim is to fetch some insight from the data, some results from your data, and you want to show them to the community, to the audience. Fortunately, Python makes creating visualizations easy with the help of two basic libraries, I would say. One is Matplotlib, another one is Seaborn. So Matplotlib is a library in Python that enables users to generate visualizations like histograms, scatter plots, bar charts, pie charts, and much more. In contrast to that, Seaborn is a visualization library that is built in the top of Matplotlib and provides data visualizations that are typically more aesthetical and more statistically sophisticated. So if you want to have more sophisticated, more fine-tuned plots, then you must go for Seaborn. Else, if you are having some basic plots only, the basic requirements, then you can go with Matplotlib. So in any ways, you can build good charts. I'll be showing you a comparison. So what I'm going to do today, my flow of work for today is that we are going to take a data set from Kaggle, that is a FIFA football match data set. It is a complete FIFA 2019 data set that we are going to take, and we are going to do some analysis from it. Okay, so I hope all of us are ready for this complete data visualization process that we are going to see. Okay, so with all good hopes, let us go about the practical part. Fine. So guys, where is our data set? Let us talk about our data set. So this is, the visual of Kaggle from which I have downloaded this data set. This is FIFA 19 EDA data set. So this is a cleaned FIFA 19 pair data set. So because this session is completely dedicated only to data visualization part, and it does not contain any other pre-processing. So that is why we are going to work with a clean file. Okay, so this FIFA 2019 dataset is a clean file. You can easily download this data from Kaggle. You just need to log into Kaggle with your Gmail account, and through that you can just search this FIFA 19 dataset, and through that you can download it. So here you will get that CSV file that you can download. Okay, and through that I am importing my data set and then working on this data set. Okay, so let me take you to that part. I'm just sharing another screen with you. Okay. Okay, so this is the actual Kaggle file that you can see. This is the Kaggle data set that I have opened through network. So you can see this FIFA 19 EDA data set. And here you can find that CSV file. You can download the data set from this link. And here you can see there are 18 columns completely in our data file that we have done. We are going to download ID. Then it is the name of the player that you are getting. You can see the names such as Cristiano Ronaldo, Messi. You can see all these big players' names. So this is a real-time data set of FIFA Football 19 World Cup. So this is the age of each and every player, the nationality, the overall rating of each and every player throughout the season, and this is the potential. Okay, this is the club to which they belong to. It can be Barcelona, it can be German, it can be Manchester United, Manchester City. You all would be knowing all this data because this is a very you can say popular game and popular World Cup. So I've taken that popular data set only. So the value is given over here, the wages, the wages in dollars, it is euros, sorry. So it is in it's in euros, and then it is preferred foot, okay, with which they actually go into goals. So that is left or right foot. So we have quite interesting data set with us. Now we need to extract extract some insights from that data set through visualization. I'm not going to implement any machine learning algo because I don't want to do any predictions over here. I just want to see this particular data set and I want to explore it. So basically my purpose is going to be exploratory data analysis. I'm totally going for EDA, and I will be limiting myself only to getting insights from the data. I have some specific questions in my hand and I will be visualizing this data for those solutions. Okay, so let us see how we are going to do this. So I've already pre-made things for you so that we can discuss this complete project. So we are going to work with data visualization using Matplotlib and Seaborn, and we have downloaded this 1590 FIFA 19 dataset from Kaggle. So here I have given the link also, and you can directly download it from Kaggle. So the first step that we have to start with the coding is to download and import the basic libraries that we require. So that basic libraries are three basic libraries that I will be using. One is pandas, second one is numpy, third one is matplotlib. Okay, afterwards we will also be using seaborn, but as of now we are starting just with matplotlib. Okay, so for that purpose I have to import pandas library, because as we know pandas library is used to actually import the data set and bring it to your current file. It will bring your data set to the RAM part of this current file, current Jupyter notebook, and will help you to create a data frame out of it. After you create a data frame out of it, you can actually start manipulating your data, and you will be able to put on some algo or apply some graph, apply some plot code to it. Fine. So I've imported pandas, and the short form I've taken is PD. Similarly, I have imported NumPy and I have taken it as alias name is NP. Secondly, we are going to import the pyplot module of matplotlib library. So matplotlib library, as we know, is this word matplotlib is made up of two main words, that is mathematical plotting. So ultimate aim is mathematical plotting of the data. That is, that is a combination word that you are getting today, that is matplotlib, mathematical plotting library. Fine. So this matplotlib is, it has a sub module which actually allows you to create and visualize that graph. So for actually showing that graph, you need pyplot sub module. Matplotlib will create the graph, but in order to show that graph, in order to display that graph, you need Python plot graph. So pyplot is the short form for Python plot. Okay. So matplotlib.pyplot you need to import. So this is import matplotlib.pyplot, and the alias name that we are taking is PLT. Okay, we are going to use this PLT. Now I have already downloaded this FIFA Football 19 World Cup dataset, and this dataset I have kept at a drive. So this drive is a D drive, and I already take this subject data visualization and storytelling. So I have this folder. So I have downloaded this file FIFA EDA dataset in a dataset folder. So, okay. So just remember guys, when you are working with Python and you are putting some absolute path over here, then while putting the absolute path, you have to make changes to that absolute path, because you can say the slashes, these need to be as same as the URL slashes. You can see the URL slashes over here. So the slashes should be same as the URL slashes. Okay, they should not be reverted. So this particular trend should be followed by you. You have to keep that. So always try and give the absolute complete path starting from your drive to your data file. Anyways, so let us come here. So I have just imported this complete. I'm reading the CSV file in a data frame known as DF, and I'm trying to visualize that DF. So now you can see when we are showing this data frame, we can see this complete data file over here, in which is now loaded in a data frame. So you can see a data frame created over here, which has ID, name, age, nationality, overall potential, club, value, wage, preferred food, international reputation, skill, moves, position, joined, and contract valid until height, weight, release cost, everything. So you can see this complete data set over here. Fine. So total, the shape of this data set, the complete shape, if you want to see the shape, it is 18207, 18. So when I say I want to see the shape, That means I want to see the rows and columns, the number of rows and number of columns into it. So when you visualize the data set even, then also you get this complete information that you have 18,207 rows. This data is something around 15-16 kilobytes. Okay, 15-16 kbs the data is. So this is a good data for hands-on to a visualization part. So it has 18,000 rows and it has approximately 18 columns. So we'll be working with this and we are visualizing the shape over here. Fine. So now let us begin with how we can work with the first type of graph that we have. Suppose we are starting to work with histograms. Okay. Now, why histograms are used and when histograms are used? So guys, when you have one complete column of data and you want to see the frequency of occurrence of data, you want to see the distribution of data, okay, then you are going to visualize histograms. So histogram actually works on a single dimension where you want to visualize the frequency of occurrence, or in simple words you can say where you want to see the distribution of data, the ultimate distribution of data. There you actually going to use histograms. Okay. So let us talk about histograms quickly. So histograms, when you are analyzing a new data set, then researchers are often interested in the distribution of values for a set of columns. So one way to do so is through histograms. Histograms are approximations to distributions generated through selecting values based on a set range. So ultimately what we are trying to do, we are trying to see that distribution of data by organizing that data in some bins. Okay, bins or buckets you can say. So those bins you can give the number of bins yourself, the number of buckets you can give yourself, or you can just use formulas for that, or in fact through statistics, if you know about Sturgis rule, then through Sturgis rule you can calculate that. So I'm just going to show all the techniques to you. So what we are going to do, we are going to visualize the distribution as a histogram in straightforward using matplotlib. So suppose we want to see the distribution of overall data. So just see over here, we have this column overall. So this gives you the overall rating of the player. Okay, so you want to see the overall distribution of this column overall ratings. So you want to see the distribution. This is a pure numeric column. You can see that this is a pure numeric column. The data type is totally integer. So it is quite easy for all of us to visualize this data, okay, through histogram. So I'm just going to see the distribution of this particular data through histogram, right? So just see how we are going to do that. So we are using the hist method of matplot library. So we have already imported matplotlib's pyplot module as PLT. So this module has this hist for method for creating histograms. So we need to just give in the parenthesis the actual column that we want to plot. So the actual column is the overall column that belongs to this data frame DF, because this DF is actually the data frame that we are working with. So in the brackets, we need to give this particular column the name of that column of which we want to create the histogram. So blt.hist df, and in the brackets we have overall column. So as soon as we plot it, okay, you can see a simple histogram out of it. So this is the simple histogram that you can see. Now, this histogram is a I would say a very raw histogram. Okay. We can just see, some bars, and bars are joined because this is different from bar chart. In bar chart, the bars that we are creating, they have spaces between them. They are evenly spaced. But as far as histogram is concerned, there are no spaces. You can't see any spaces. All the bars are completely stacked up together. So they are not divided by any spaces over there. So I would say this histogram is a very rough kind of a histogram. We need proper labeling onto it. We need to set some colors. We can set some colors. We can display the edges also, the way we used to display through hand or through bar graphs. So we can do that through graph papers. Okay, I mean, so let us see. We can generate histogram by specifying the number of bins. Let us make it more fine-tuned. Now we are specifying the number of bins also. Now we are also going to set some colors. So here you can see what I'm trying to do. We can generate a histogram of any numeric column using hist method and passing in the selected column in the data frame. So we create histogram here again for overall column, and we specify the number of bins as 10. So now just see the changed code. We are doing plt.hist, and here we are again creating the histogram for overall column. But now we have some more parameters setting for us. Like we have edge color set to black. So what will it do? It will create the edges of the bars. Okay. The bars of the histogram now will have proper edges so that you can just split the bars of the histogram. Then I am also specifying the number of bins as 10. Okay. So you can specify any number, but I will, in a small while, I will show you how to calculate manually. As a data scientist, you must know how to calculate manually the number of bins. It is according to the Sturgis rule. Okay. So anyways, we are going to see it in a short while. So I am also going to give the x-axis labeling here. So I have plt.x label, which will actually give the label of the x-axis while creating the histogram. So I'm giving the label as overall. And again, I'm giving the label for the y-axis as well. So you can see plt.y label, and we have here frequency. So I am plotting the x-axis overall, and I'm going to see the frequency of occurrence of data in that overall column, because I have 18,000 plus rows. So I have 18,000 plus data with me. So I will arrange this particular data in a form of distributed bars in histogram. So just see, I'm also giving the title over here, histogram of overall player ratings in FIFA 19. And finally, we are going to display that graph through plt.show. So you can see over here now a much better labeled histogram. You can see where you have a overall title, then you have this y-axis frequency, then you have x-axis overall column that actually has the data. And here you can see the histogram is also edge separated because you have given this edge color. So it is edge separated also. Fine. So this is how you can create a fine tuned, a more better tuned histogram. So this looks far better as compared to our earlier diagram, which was totally a rudimentary or a raw diagram. Okay. So let us make it more scientific. Fine. So let us make, how we can actually give bin usage. Fine. So we can set the width of the bins also. Fine. So how we can set the width of the bins? Now here you can see the default width of bins. It is 50, 60, 70, 80, 90. So default width is going to be 10. So I am going to now separate it. I am going to just take the width myself. Fine. How we can do that? So how I can specify the width? You can see over here, we can specify bin width to use. I am specifying a variable width over here. The width variable has value 10. Now I'm again plotting this histogram, plot histogram. I'm again plotting this for overall column. Edge color is again black. Now here I'm putting a formula. Earlier you could see I put it bins equals to 10, where I was just numbering that number of bins as 10. I was not doing any specific calculation for it. But now I'm trying to distribute the bins. Okay. So how we can do that? Just see over here. So I'm giving bins equals to numpy. I'm using the numpy library now. So numpy dot range. So I'm giving the arithmetic range over here with minimum value in the overall column. So I'm using the min function just to get that minimum value in the overall column and maximum value in the overall column. So this range, numpy range, will work from the minimum to the maximum value in the overall column. So this is the way how to fetch the minimum value and limit it to the maximum value in the overall column. So this plus width. So what I'm trying to do, I'm starting it from the minimum range and I am moving it till the maximum range plus width. Width means the whatever the value you are giving. So I'm giving the value as 10. So it will move till the maximum value of the overall column plus that 10 value, comma width. So that, the range is going to be separated by 10 steps. So the width is going to be actually the 10 steps. And here I am generating the actual labels for that x-axis. Fine. So I am going to give the label for the x-axis, y-axis label, again the same thing, title, and you can see the show function for actually showing the histogram. So now when you have created this particular data, now you can see there's a difference here. The bins were more. Okay, there were total 10 bins that we were creating. The number of bins was 10 over here that we were doing. And here the width of the bin is actually 10. Here we have specified 10 as the width, and you can see this complete, there are only 5 bins that you can see now. There are not 10 bins for 15 bins. There are just 5 bins, each having a width of size 10. And it is, having the range starting from the minimum value till the maximum value, and the width that we have given as 10 units. Okay, so I hope this is getting much clearer to you. Once you will get this code now, then you try to do it, implement it yourself with different values. Okay, you can just minimize the width to 5, or you can increase the width to 20 and then see the difference in the outputs. Okay, so I just I'm giving you a glance on the code, how it works. But ultimately, when you get this complete code, try to work with different data with it. Okay, anyways, now the important factor when we are creating histogram is that number of bins. Okay, you can see the same data with 5 bins, you can see the same data with you can say 10 bins approximately. Now, how and what should be the criteria for selection of bins in histogram? How we can do that? So we now know that it is a very, very crucial question of calculating number of bins in a histogram, and these number of bins have a very, very deep impact on how you are going to analyze and interpret your data. So that is so because if you are going to use a very less number of bins, then the patterns that you could have seen in the data, they get shadowed. Okay, so if you are using very less number of bins, few bins, then there would be data shadowing because the trend will be shadowed. Okay, because ultimate the trend or the pattern that you wanted to see will be hidden from you. And if you see, if you are going to use a very, very huge number of bins, then ultimately it will create noise in the data. So you will be visualizing a lot of noise in the data. So just be very, very careful about it, that when you are using a histogram, that number of bins should be calculated very, very specific. Okay, so fortunately we have a method which is known as Sturgis rule to determine optimal number of bins to use. Now Sturgis rule uses a formula that I have shown here. Optimal number of bins is a ceiling function of log 2 to the base n plus 1. Now this formula, how does it work? It takes the base 2 logarithm of that n. Now what is n over here? N is the actual data that you are going to take. So this particular overall column that we were showing, overall rating column, so that becomes your n over here. And that complete, you are going to take the logarithm of values and you are going to add it up, and then finally take the ceiling function and you get the output out of it. Okay, so how we do this for this complete data? So I have all in all a total the number of data, the number of values, the number of observations in this particular column. So I have 18,207 observations in this column. So I'm going to take the logarithm, base 2 logarithm of these number of observations plus 1. Okay, so that makes the binary logarithm is approximately 14. So once you add 1 to it and take the ceiling, you get approximately 15 number of bins. So in order to view such huge data, guys, remember this always, that the range of bins should be from 10 to 15 always. Okay, don't go for more than 15 bins. Okay, because it actually leads to noise in your practical data. So if you see over here, I am doing this for 15 bins. If you have 10,000 plus rows, because in a data sample, we assume that the number of rows are going to be 10,000 plus. So if you have 10,000 plus rows, then directly you can try doing it starting from 10 bins and slowly move and see the data till 15 bins. So it is a good practice to use, in the range of 10 to 15. Okay, so I am trying to do it for 15 bins now, because according to Sturgis rule, I am getting number of bins as 15. So I'm going to do this for 15 bins. So plot.histogram, again, I'm using the data frames overall column, and I'm using the edge color as black. Now face color, another parameter I'm using it here is face color. So face color actually modifies the color of the graph, the color of that bars that you are going to see in the histogram. So if you want to give the colors of the edges, then you can use edge color. If you are trying to give, the color of the front end of that bars, then you can give the parameter as face color. So this parameter modifies the color. Okay. Now bins. I am giving the bins number of bins as 15 and the range. Okay. The range actually specifies the data. Okay, so the range is going to be starting from 50 comma 90. So I've taken it here because I already know that the range is going to be 50 till 90 as per my data. But if you do not know, then I have shown you the earlier methodology where you can give the range through this minimum of the value, then maximum of the value, and then width. So you can use this range formula also. But I wanted to make it quite understandable for you. So I've shown you different ways of doing things. So here I am taking the direct value as 50 to 90. Okay. But you can use the formula also. That is totally okay. Fine. So here I am again giving the x-axis label, y-axis label, the title, and I'm going to show this value. So now you can see the overall, the best histogram that we are getting. So this is the ultimate very sharp histogram where we have modified the colors also. We have modified the x-axis values that we want to see, and we can, specifically we can see which rating, the overall rating which have been present in the maximum number of players. So we can see over here the maximum players are in the range from 65 to 70. So this is the bin range which has the maximum, this is the basic overall range, overall rating which maximum number of players have. So this frequency you can see above 3000. So above 3000 means more than 3000 players have this overall rating of 65 to 70. So this has been the most average rating, the most present rating of the players. Okay, so this is how you can get insights from your data by fine tuning your plots. So I have tried to show you what all you can do with histograms. Okay, so I hope now you all have a fair idea of how to create histograms, how to fine tune its parameters like face color, like edge color, how to give number of bins. You can hit and try starting from 10 bins. You can use formula with ranges, and finally you can also use Sturgis rule to calculate number of bins according to the data, the number of observations that you have. Then you can use that complete Sturgis rule to create your histogram bins also. And finally you will actually get a very fine-tuned histogram, and you can get the insight of the most occurring, most frequently occurring data from your data set. Okay, fine. Anyways, let us go about the next plot. So before we go to the next plot, let us see what types of data columns we have. So I'm simply using df.d types. So this particular you can say property will tell you the data type of each and every column present in your pandas data frame. So you can see over here each and every column and its data type you can see. So always remember df.d types. This should always be checked because once you are trying to explore your data set through visualizations, you must be knowing in case you need to modify some data, you need to typecast some data, because most of the visualizations you can create on numeric data. So if you have some string form of data, then either you need to encode that data or you need to convert the data type from string to some integer value, right? So you can see we have ID, name, age, nationality, overall potential club, and their data set. Their relevant data types you can see over here. Okay. So let us go ahead. So the next type of plot that we are going to create is about scatter plot. Scatter plot is one of the most important, you can say, most important type of plots that we have for visualizing our data. So they are useful for data visualization because they help you to verify how two or more variables are dependent on each other. So we can say they want to find out the relationship between your variables. It may be your two independent variables, or you can take a set of independent and a dependent variable, or you can just see the how a dependent variable varies with respect to some independent variable. So if you want to see the variable dependencies, then you can go for scatter plots. Okay, they help you to see the pattern how your dependency is moving. Okay, how two variables are interdependent on each other, what is the strength of their dependency, so that we can see. In a short while we'll also see a heat map where we will be creating correlations, we'll be seeing the correlations also. So don't worry, you will be slowly and steadily moving towards seeing the dependency in details. Okay, so here we are just trying to see the two variable dependency with the help of a scatter plot. So for example, if we are interested in seeing if there is a positive relationship between wage and overall player rating, that means if player's wage increases, does his rating also go up? So I think this is a very general question that is always seen in all the data sets, that if one variable is going up as the value of one variable is increasing, does the other variable value also increases as this at the same pace? Like means it has a positive correlation, it is going upwards, or it has a negative correlation, or there is no correlation at all. So that kind of thing we can see through scatter plots, because this positive, negative and null correlation trend can be easily visualized through scatter plots. Let us see how. So we are using the scatter plot for visualization. So we are using this plt.scatter function. So this scatter function is used directly for creating scatter plots. So you do not need to do a lot of hard code for it. You have already pre-made this function scatter. So through that, giving two variables, you can create a scatter plot from them. So we first column we have taken is overall, because we want to see the effect of wages on overall rating. So at the x-axis, we want to plot overall column, and at the y-axis, we want to plot wages column. Okay, so we are giving df overall, so data frames overall column, comma df data frames wages column. So we can see the title here, we can see the y-axis, x-axis, and we are going to plot this. So you can see over here. Now here what you see, the scatter plot that you are creating. This scatter plot, each and every value, each and every dot, you can see a cluster of dots over here. So scatter plot actually plots each and every value of that data, that you can say the matching value of the data as a dot, as a point. The scatter means the points, okay? And you can see a group of all such points in the data set, and through that you can see an increasing trend. So you can see as the wages are increasing, so simply as the wages keep on increasing, the overall rating also increases. First of all, it remains, it remains static as you are increasing, but at the highest point, when the wages are increased to a very good extent, then you can see the overall rating of the player also increasing. So there is slow increase, I can say, through this data. There is positive correlation, it is increasing, it is moving upwards, but it is slow. The rhythm of that, or you can say the correlation between these two columns is positive. It is on increasing pace, but it is slow increase. Okay, ultimately what you can see, when the overall value is highest, when the wages are also at the highest. Okay, so that means the highest rating player is getting the highest wages. So the ultimate answer is positive correlation, but slow positive. Okay, anyway, so this is how you can create a simple scatter plot. The third type of chart that we are going to see is about bar charts. Okay, so now how bar charts help you? They are similar to the way we plot histograms, but histograms, they show only distribution of a single variable that we saw here for overall rating. So it was a single column of which distribution you were able to see. Okay, but now what happens when we want to see how the values are categorized over time, or how the values are categorized in a few categories, in a few classes. So you want to have some comparative graph. Okay, you don't want to see a mere distribution. You want to see the comparisons. You want to compare two or three classes. You want not two or three, but more than that. You want to compare some values and see which of them is at the highest momentum. Okay, so for that purpose, you can see bar charts. So bar charts are basically good tools for analyzing categories in data. So they are a good means of comparative charts. Okay, for example, if we want to see the most common nationalities found in our FIFA 19 dataset, we can employ bar charts. To visualize categorical columns, we should first count the values, and we can use the counter method from the collection module to generate dictionary of count values for each category in a categorical column. Now, this is something very, very hard code that we require. This is going to be a good experience for all of us. So, we have nationality column. Let me take you to the nationality column first of all. We had seen the data frame over here. So I just scroll back to the data frame. So you can see the nationality column over here. Now, one good insight to bring about can be, which nationalities are the highest present in FIFA 19 Football World Cup. So we can say whether they belong to England, whether they belong to Argentina or Brazil or Spain. So which country had the maximum nationalities, or we can say the highest number of players are present from which particular country. We can get that insight. We can have that popularity index also through the calculation of the highest number of players from which country we have. That particular popularity we can get. So we are going to use this nationality column for creating a comparative bar chart here. So for that purpose, guys, we cannot easily do that because as I told you, all these graphs, they require some numeric values. Okay, you do not have numeric values in nationality. You have just seen here, once again, please just carefully see that this nationality column has totally string values present. So you can see the first player is from Argentina, second player from Portugal, third player from Brazil, Spain, Belgium, and so on. So this is no number. Okay, this is string. So we need to create a counter. First of all, we need to count the presence of the number of times you encounter Argentina, the number of times Portugal you encounter in this data set, the number of times Brazil, Spain, England, Sweden, all these countries are present. So we need to count for each and every country the number of times, the frequency of occurrence we have for each and every value. Then only we can create a comparison of for them. So how we use this? We use this with the help of a collections module that is present in Python. So we have to hard code it. So how we can do that? So I am going to use this collections module and I'm going to import the counter class, and through that counter class directly it is going to count each and every country's frequency. So you can see over here I'm using this collections module. So from collections I'm importing counter. So collections module is used to import the counter class, and I am directly calling the you can see the constructor of this counter to calculate the frequency of occurrence of each value inside this nationality column. So I'm passing as the parameter data frames nationality column inside the constructor of this counter class, and this will actually create an object of counter. This is counter class. What does it do? See, the collections module is used to create data structures ultimately. Okay, the data structures that we used to have like stack, queues, list, etc. We already have predefined classes in Python, but if we want to create some data structure out of our data set, we want to create a list, or we want to create a heap out of our data set, we want to create a stack or queue out of our data set, we can simply use collections module if we do not want to go with the direct classes of Python. But if we want to use and create collections module with counting of the values, we have a counter class. This counter class actually creates a counter object that is going to count each and every value and number of times it has encountered that value in that data set. Okay, so I hope you are able to understand this particular thing. So counter object is created. We have printed this counter object. So counter data frame of nationality column. So you can see over here the counter object is being created, which you can see by the name counter. So this is calculating for England. So totally England is encountered 1662 times. Germany is encountered 1198 times. Spain 1072 times. Argentina 937 times. So you can see it is printing that it has counted and organized the data in the form of decreasing order. Okay, so you have the highest value of England, then Germany, then Spain. So you have already counter has already sorted this data in decreasing order. So it is, starting from the highest and going to the lowest. So you can see all the countries over here, as many countries as were present over there, and there were around, you can see so many countries, 72 countries over there. So you have Botswana, value 1. So this is the lowest value that you are getting. So we'll also create bar charts. We have methods of calculating the highest occurrences, lowest occurrences, and everything. So I'll be showing you every aspect of those things. Okay, so don't worry. So now we are going to use filter. Now we want to have only, the most, you can say, the most highest nationalities which is present. So the countries which have the more number of nationalities present, we want to find that. So how we can do that? So we need to filter the data. So you can see over here, this object, counter object, is in the form of dictionary. If you carefully visualize it, last time we did about dictionary. So in dictionary we have key value pairs. So you can see this dictionary has this key as England and its value 1662. Similarly, the next pair in this dictionary is Germany and 1198. The next pair is Spain, 1072. Next pair is Argentina, 1937, and so on. So this complete is a dictionary where you have each country and its corresponding frequency of nationalities. So this is in the form of key value pairs. So this dictionary is already created. Now we have created this dictionary. Now we are going to filter that out and we are going to get only some 10 most common, yeah, or you can say the most highest occurring nationalities. Okay, how we can do that? So we are using filter for this by using most common method of dictionary. So we are going to use this particular method of dictionary. So how to get the 10 most common nationality values? You can say print. Now we are using dict method, which will actually create the dictionary object. So dict method is actually a dict constructor, which we are calling over here to create the dictionary out of the values that we get in the parameter. So you are giving the parameter as counter parameter, df, data frame of nationality. Then you have used this most common function, and in the parameter you are giving 10. So that means you are trying to call 10 values, the 10 most common values, because counter has sorted values. You can see we have already seen the counter has sorted values. So most common function will return you the highest 10 values that you have. Okay, so it will convert that result. This result will be converted back into dictionary once again through dict method, and it will be printed. So you can see this is the ultimate dictionary of the most common nationalities that we have. So we from England, Germany, again in the decreasing order, you can see England, Germany, Spain, Argentina, France, Brazil, Italy, Colombia, Japan, and Netherlands. So we have these 10 countries and the highest number of nationalities of players present from these countries we have. Now we want to also, I will create two bar graphs. One would be for the most, common nationalities. One would be the least frequent nationalities, okay, which had one or two players maximum present. So I'll be doing it for both. So I'm also side by side calculating the most infrequent nationality values. How we can do that now? Just see, when we want to revert back, we had seen in the previous session with me, I showed you how we can reverse that list of values, how we can reverse that dictionary of values. So for reversing the code, we are using here, again, most common method. But with this, we are using the reversing. We are using the slice method with reversal. Okay, let us see. So we are analyzing the most infrequent nationality values. So we are saving this in a variable, say least common, equals to, again we are using the counter function. Now counter function will again be used with the nationality column, and this time again we are calling the most common method. You can see over here I am calling the most common method with reverse. Okay, so we are just taking the reverse because I want to see the most infrequent values. Now just see in the data frame, the most infrequent values are at the bottom, at the last. So if I want to fetch the most infrequent values, I need to fetch this dictionary from the last value. Okay, so I'm trying to fetch these values from the reverse order, the last value first. Okay, so this way I'm doing most common slice. Okay, I'm using double columns just to make sure I'm starting from the most first value and I'm going to the last value. And reverse order I want to see, so the jump value, the steps I'm giving as -1 because I want to start seeing from the backwards. So print, now I'm printing it, print this least common. So this actually what happens, this counter will store the values in the form of list from this dictionary. So this dictionary will be stored in the form of list in a variable say least common. Now I want to slice it down to the most infrequent 10 values. So that is why I'm slicing it once again from 0 to 10. So it will take the slice values from only the 10 values out of all the complete dictionary, complete list. I am only trying to fetch the last 10 values. So it is 0 to 10 that I'm getting. So you can see last values, Botswana, the last value was Botswana. So since you have reverted the list, so you can see the first value in this list as Botswana. Next value was Indonesia. The second last value was Indonesia. So while calculating the reverse order, you can see Indonesia at the second point, South Sudan, then you have Belize, Malta, Andorra, Qatar, Rwanda, Jordan, Grenada. So you have these you have these 10 countries. So till here. Okay. Now, when I'm seeing these most infrequent nationalities present, we have only single values present over here. So this is not going to give me a good bar chart. So I need to, enhance my range. Just to see a more comparison, I need to enhance my range. So this time I am again seeing this list common, but I am slicing it from 0, not from 0 to 10, but slicing it from 0 to 30 values. So I want to see the 30 values. So you can see these 30 values give me a little bit of more range of values, where I have some countries which have only single personalities, then some countries which have two people out there, two candidates, two nationalities. So this will be a better comparison as compared to single entities, right? So I have taken it. So you can also one idea that you can draw from here is that when you are creating comparisons, then you can increase your slices as per your requirement. Okay, if you feel that your slices that you have done till now, they are having almost same values, no bar charts could be, good comparative bar charts can't be made, then you can increase your range, you can increase your slices, number of values that you can have. Okay, so finally we generate the bar plot of the most common 10 nationality values. We simply call bar method. How we can do that? See, nationality dictionary, I'm creating a nationality dictionary first of all, then I'm calling the dict method again. Now, on what I am trying to call the counter, and I'm trying to call the most common 10 nationalities. I've already shown you what will this code do. This code here will print the 10 most commonly occurring nationalities. So this time I am not printing it, I am creating a bar plot out of it. So I am directly using this. I am calling the counter function on this nationality. Then I'm calculating the most common 10 values, converting them into dictionary and storing them in nationality dictionary variable. Okay. Now in the bar chart, I'm calling this plt.bar chart. This will call the bar chart. Now here, what actually I want to create? I want to create a bar chart on the key value. So you can see here in the dictionary, the key is actually the name of the country. So we want to see the names of the countries in a bar chart. Okay. And the plotting should be done based on the values. So remember this always. What label should be there? The labeling should be this key value. So you want to have this key value on the x-axis, and the y-axis comparison, the actual value of the plotting should be on this y-axis. So how you are going to do this? Just see over here. We are using the bar function, plt.bar. Then we are saying nationality underscore dictionary dot keys. So this keys will be on the x-axis, and nationality underscore dic dot values. Now y-axis will have that value plotting. Okay, that value, till that value only the bar chart will be plotted. So we are giving the x-axis label as nationality, y-axis label as frequency, and title as the bar plot of the 10 most common nationalities. Okay, then we are showing this bar plot. So now you can see the bar plot of the 10 most common nationalities over here, and that too, in a quite sorted order. So but this visualization I will not say is a good one. Why so? Because you can see on x-axis, the names of the countries are messed up. You can see all these names are messed up. They are, interfering with each other. The labels are superimposed with each other. So we do not want this kind of visualization. We want to have a good visualization where all country names should be visually easily visualized. Okay, they are visually available to you. So how you can do that? You can simply do that by uh, you know moving or rotating the names by 90 degrees. What I said, I mean the x-axis, these names of the countries, these key values should be rotated by 90 degrees. Just see how change it would be done. Just see the output, then I will show you what code it is. Now it is a better idea, better graph, where you are seeing the bar plots. So you can see this bar plot is having each and every bar plots country is available to you. So what I've done, I've simply rotated the names of the x-axis of the bar plot by 90 degrees. So earlier they were seeing horizontally. Now after rotating them by 90 degree, you can see them vertically. So you can see all the countries easily, visible to you. Now, what is the code for this? Just see over here. Again, I am creating the same thing. I am creating a nationality dictionary. I am using the dict function counter df nationality most common. So I am just fetching the most common 10 nationalities. Then I am plotting the bar plot with the same code, exactly same code as we have done above. Nationality dictionary dot keys, nationality dictionary dot values. Okay, so we have done this. X-axis label, Y-axis label, title, everything same. The only thing that is different is this particular function, xticks. Okay, so xticks method is actually used to tick out. Okay, this word tick means ticking out of the x-axis values. Similar to this, you also have yticks function also in matplotlib. So xticks rotates the values on the x-axis by the number of degrees that you give. It can be 90 degree, it can be 180 degree, or anyways you want it slightly, slided, then you can give 45 degrees. So it depends on you what kind of value you are giving. So it is used for rotating that value. The ticking of that values could be there. Okay, the name has been taken the way your clock ticks. Okay, the clock is moving in the form of angles now. You can see the second hand ticking in the form of angles. Sometimes it is at 90 degree, then it is at 0 degree. If we say at 12 it is at 0 degree, then it reaches to 45 degrees, 30 degree, 45 degree, 60 degree, 90 degree, and 180 degree, and so on. So it keeps on ticking in the degrees. So rotations can be given through those values. Okay. So plt.xticks rotations equals to 90 and plt.show. So now you can see just keep rotating values by 90. You can see simply the reverted values. So this is how you can do this. Very, very easy thing. I am not doing this for y-axis because y-axis values are quite easily visible. So there is no need to do this. Okay. But if they would have been messed up, then we would have done something with xticks also. Okay. Now, the next part. Let us go to the next thing quickly. So, we also wanted to plot the most infrequent values also. Okay. I wanted to plot the most infrequent or most least commonly present nationalities. So how I can do that? I can simply use the same thing but with least common value. So if you see over here the code, I had already calculated the least common value. We had calculated the least common value over here by using the counter on nationality column, then calling the most common function and taking the reverse of the list. So we have taken the reverse of the list. Okay, and through this reverse we have got these values in the form of list. Always remember this variable stores the values which were earlier in the dictionary in the list. Okay, now this variable will store the value in the form of a list and not dictionary. If you want to create a dictionary, you need to use dict function for that. Okay, if you are not using that dict method, then by default all the values will be stored in the form of a list. Okay, and this list, if you see the output of this list is a combination of tuples. So you can see the first tuple is Botswana, comma 1. So the name of the key, that is the country with its value of occurrence, that is 1. In the same way, Indonesia 1, and so on. So we have already calculated this least common list. So I'm just directly using this least common now. So I'm doing this what? I am going here. I am doing national dictionary, nationality dict. I am creating a dictionary now. nationality dictionary equals to dict method. Now I'm converting that list of least common. That list is now converted into dictionary with the help of this dict method. Least common 0 to 30. So I've taken that slice of 0 to 30, and that 30 values from this list of least common will be converted into dictionary and stored in nationality dictionary. So plt.bar nationality underscore dictionary dot keys. Again, it will make it up for keys and values the same way we did above. Okay. X-axis we have given, Y-axis frequency, X-axis nationality, title, bar plot of 10 least common nationalities, not 10, but you can say 30 least common nationalities. My mistake, I have written here wrong. It has to be 30, not 10. Okay. plt.xtick. So I am using xtick once again. Rotation is 90, just for better visualization. And now I'm showing plt.show. So you can see over here the bar chart is not giving you very good comparison, but it is showing you one thing, that all these 20 countries, or say 25 countries, they have only single nationalities present. So the value they are plotting is against one. So on the y-axis, you can say only one value is there, which is being plotted. And the next, you can see these six values, out of the 30, these six values have nationalities. They are two in number. So these countries have two players, okay, maximum two players, and these 24 countries, they have, you can say, one player each. So these are the most least common nationalities present in FIFA Football World Cup 2019. So here you have these two bar plots, one from most common, next from least common. Okay. Now coming to the next bar chart, let me take just a break of 1 minute. Let me have water, then we'll continue. Okay guys, so now the next type of data is like we want to see the proportion of players. We want to see how much percentage of players belong to which country. We have just seen over here nationalities, we have plotted, we have compared it. Now we want to see the proportion in the terms of percentage. Like FIFA Football World Cup 2019 contained 100% players. Now out of that 100%, what percentage of players belong to England? What percentage of players belong to Germany? So when you want to actually see, the proportion, okay, you want to see the percentages, then you go for pie charts. Okay, so how we can see, for example, in this data set, we can use a pie chart to visualize the proportion of players, say from 4 countries. I have taken 4 countries: England, Germany, Spain, and Argentina. So I am doing it for 4 countries: England, Germany, Spain, and Argentina. And apart from these 4 countries, all the other nationalities are in a single variable, which is other. Okay, so before we actually begin with pie chart, I want to tell you one thing. On real-time basis, when you create pie chart, do not mess it up. Okay, do not use a huge number of categories. Do not use 10, 15 categories. No, it should not be there. If you want to see 10 most commonly occurring 10 things, or such kind of things you want to see, or you want to see comparison of 10, 15, 20 values, go for a bar chart. Pie chart and bar chart both are used for comparisons. Both are good tools for comparative charts, but they, serve their purpose only when clarity is there. Pie chart becomes messed up when you have more than five, you can say, five values of comparison. If you are going above till 6, 10, 12, 20 values, the pie chart will be totally messed up. So suggestion for visualization is, when you have, take a goal, if you have more than 5 or 6 values, okay, mostly you can take 6 values maximum, or max to max you can stretch it to 7, but not beyond that. Okay, because you're, if you take up more than 6, 7 values, then ultimately the angles would be very, very reduced. Appeal of that pie chart will be totally messed up, so it will not be very attractive visualization. So take your goal. If you have 5 or 6 comparisons only, go for pie chart. If you have more than 5 or 6 comparisons, go for a bar chart. Do not use pie chart. Okay, so I am doing it for 5 things. I'm doing it for England, Germany, Spain, Argentina, and rest of everything goes in other value. Okay, other nationalities. So what I'm going to do, I'm going to locate the nationalities first of all. So I'm using df.loc. So I'm using data frames location. So I'm location. This loc value will take specific column. Okay. So I am taking df.nationality column, and in that nationality column, wherever the value is England, I am taking that value. Okay. And I am putting that value, okay, that row, that data value in nationality underscore 2 column. Okay, so I am just putting this under the heading nationality underscore 2. I'm locating this. So what I'm doing, I'm telling you once again, I am locating the nationalities where England is present, and I am putting that value under the name nationality underscore 2. This will create a new temporary column. Nationality underscore 2 will be a new temporary column that will be created. Okay, and England values will be put into that, and it will be by name England. Okay. Similarly, again, I will be locating the nationality value Germany in this nationality column, and I will put all those values under the column nationality underscore 2 with the name Germany only. Similarly, I will locate the nationality values in the nationality column. The value is Spain. So I will copy this value Spain in another column by the name nationality underscore 2, and the copied values will be with the value Spain only. Similarly, I will go to nationality where Argentina is there. I will put that under the column nationality underscore 2 with the name Argentina only. Okay. Lastly, what I have done, I have taken these 4 specific values. Now I want all other values under the name other. Okay. All the values, whether it is Brazil, whether it is Brussels, whether it is Japan or any other country, that should be put under the name others. Okay. So I am again trying to locate, and I'm saying this time not. I'm using this tilde operator, which is exactly the not operator. So I am using this tilde to specify in the data frame where nationality is in England, Germany, Spain, and Argentina. So I am taking the reverse of that by using this tilde. So I ultimately what I'm doing, wherever the nationality is not in England, Germany, Spain, and Argentina, that should be put under nationality underscore 2 column. All the values will be put in under this column with the name other. So if we have, suppose, say the nationality is Japan. Okay, so it will not be present in this, you can say this list, England, Germany, Spain, Argentina. So it verifies, it qualifies to be in this category because it is not present in these 4 list of values. Japan is not there in England, Germany, Spain, or Argentina. Japan is beyond these 4 values. So it will be put in nationality underscore 2 column with the name other. Okay, so the name other will be given for Japan. Similarly, we say for Brussels, then Brussels is also not present in these 4 values of list. It will again be copied to nationality underscore 2 value by the name other. So every time you encounter any other value apart from England, Germany, Spain, and Argentina, that would be stored in nationality underscore 2 column with the name other. So this is what we wanted. Okay. Now we are creating a dictionary now. Why dictionary? Because we need to calculate their proportions also. Up till now, what we have done, we have created a new column with the name nationality underscore 2. We have copied the England, Germany, Spain, and Argentina values and all the other nationalities with the name other in this column of nationality underscore 2. Okay. Now we want to create a dictionary which will contain each country name and its proportion associated, the percentage of values associated with it. So how we can do that? We can say proportion equals to dictionary. I'm creating a dictionary. I'm again using the counter. Now I'm using this counter constructor on nationality underscore 2 column. Earlier I was using it on nationality column. Now I'm using it on nationality underscore 2 column. So I'm using it for nationality underscore 2 data frame. Okay, I am counting it through counter constructor. I'm creating a counter object out of it. Now this counter object will be converted into dictionary, and this dictionary will be stored in proportion. Okay. Now, through this, I actually need to create proportion. I have not created proportion. This counter will count the number of occurrences. It will count the England, suppose 1,000 times England was there, 200 times Germany was there, 300 times Spain was there, 100 times Argentina was there. So frequency of occurrence will be counted by counter, not the percentage. So you have to manually do that. How you can do that? So I'm doing it for key, comma, value in proportion dot item. So this proportion is now a dictionary. So I'm just using a for loop over here. So I'm using for key, comma, values in proportion dot items. Now I am creating the particular you can say proportion or percentage by saying proportion key equals to, the key will be values divided by length of the data frame, the complete number of values. Length of the data frame will give you the total number of observations, which will be 18,000 something. Okay. So values, each and every value that you have taken in this dictionary divided by the total number of observations, that is 18,000 observations, multiply by 100. So this values would be, first time it will be done for England. So first time England would be, what would be their proportion value of key would be equals to the values of England country divided by total number of observations multiplied by 100. Second time it will work for Spain or say Germany. So key value means proportion of Germany would be equals to the total values of Germany divided by the total number of observations, that is 18,000 multiplied by 100. So you can see it will give you first of all Argentina 5.14. Then it will give you others, which will be 79.83%. Then it would be Spain 5.88% and England 9.12%. So you ultimately have a dictionary which is proportion dictionary, which have the name of the country, and that country, okay, the key of that country is having the value of the percentage or proportion of the nationalities that it has. Fine. So Argentina nationality is 5.14%. Others are 79.83%. Spain is 5.8%. England is 9.12% and so on. Okay. So how we can do that? Just see over here. We are now trying to do it for pie chart. So I am plotting this for pie chart. So I am doing plt.py proportion dot values labels proportion dot keys. So I'm doing it for pie chart. I'm creating a pie chart. In the pie chart, first of all, I want to give the values with which I want to make that pie chart. So that is proportion dot values, because these are the actual values now which will be plotted. This 5.14, 79.83, 5.88. These will be the actual values that will be used. Okay. So you are going to use these values. Plotting of these values will be done. So I'm putting proportion dot values as the actual values to be plotted. Labels. Now labels means the labeling of this pie chart should be done with the names of the countries. So names of the countries are stored as keys. Okay, you can see Argentina, other, Spain, England, Germany, so on. So you can say labels equals to proportion dot keys. Now we also have this auto PCT. Auto PCT is what? It helps you to label the percentage. Auto percentage. PCT means percentage. So automatically, if you want to visualize the data, visualize the angle in form of percentage. 5.14%, 9.12%. You want to visualize that in form of percentage, you can give auto percentage. And this format specifier uses percentage symbol to specify the format. So you can say percentage 1.2f. Why 1.2f? This means before decimal point, one letter should be there. And after decimal point, you can see, after decimal point, you can have maximum two values. So it shows you that after decimal point, minimum, this one shows the minimum value before percentage can be 1, maximum it can be 2. And after dot value, the number of decimal or floats can be only 2. So that is why I've given 1.2f. So you can see over here, when this pie chart will be plotted, the labels are the country names, Argentina, England, Spain, other. And in that, inside the angles, you can see the percentage value through this auto percentage. So you can see before dot, you can see 1 or maximum 2 values, that is 79. Or if it has to be 100%, then maximum it can go to 3 values. Okay. So before point, you can have minimum 1 and maximum 2 or 3 values, whatever they are. And after percentage, specifically, you are saying 0.2f. That means we have only two values after decimal symbol. Okay, so after this dot you have 84151389. So this ways you have these values. So auto PCT will actually label each and every angle or pie of this pie chart. Okay, each and every you can say slice of this pie chart will be labeled with that percentage. And then you are giving the size also. PLT dot figure, the figure size is going to be 10 7. That means horizontally it has to be 10, it has to be 10, and vertically it is 7 points. Okay, so this is the general figure size we use. You can make it 10 comma 10. Okay, width and height you can specify in points anyways. Okay, whatever is your device, you can say device dimensions, according to that you can give. Okay, so I've given it 10 comma 7 because it was quite easily visible in this format. Otherwise you can give it 10 comma 10. The size of the figure will be increased, but do not stretches it more because it will lead to, pixels will be smudged in that case. So in order to prevent the smudging of pixels, just keep the picture in a good grid only. Okay, in 10 comma 7, 10, 20, 10, 10, so on. Don't stretches, overstretching don't do. Okay, so we are doing PLT dot show. So you can see a pie chart where it specifies that Argentina, England, Spain. Okay, by mistake, I forgot to write the code for Germany. Maybe by some mistake it happened. So you can, anyways, you can just, okay, fine. I made a mistake in code over here. I forgot to write a Y. So that is why it is not taking Germany. Just make sure you don't do that mistake. Fine. So you make it for Germany. Just put a Y over here, and then here that Germany spelling was wrong from my end. That is why it is not showing the slice of Germany. So if you just make it, then it will show. Because it is, what is happening. Here I have taken German, so German is also going to other. So that is why it is showing you 79%. Otherwise, a good share of Germany would also have been there. Fine. So anyways, the basic thing is clear to all of you that how you can create a pie chart of it. You can also explore the pie chart if you want to see one specific country highlighted. You can explore the pie chart. You can see this pie chart where this pie chart is exploding. The England value is highlighted. So this England is, moving out. So it is showing you 9%, a good value, good share of percentage of nationalities present in this pie chart. So in order to separate out a slice, you can explode it by giving explode tuple. So this 0, 0, 0, that means 0, 0, 3 values. Total we have 4 values in this pie chart. So 0, 0, 0 means all the values will be at center 0. Only 0.3, 0.3 is a specific value. So the value present at the fourth place will be going slightly 0.3 points apart from the center. So it is going 30 points apart from the center, you can say. Fine. So the rest of the values are same. PLT.py, proportion dot values, labels, proportion dot keys, auto point 1.2%, auto percentage. Now explode equals to explode. This explode parameter is taking this explode tuple where we are specifying the, the exploding value. So all are at center. Only the last value 0.3 because it starts in anti-clockwise direction. Na? So it starts with Argentina. First value is going to be Argentina. Second value is going to be other. Third value is going to be plotted Spain. Fourth is going to be England. So that is why the fourth explode is going to be a little bit higher because I wanted to explode England value. Okay. Anyways, this is how you can create a pie chart. Okay. Finally, we are okay. This I think is repeated. Okay, forget it. Forget it. This we have done already. Bar chart. Now I'm going to seaborne plots. Okay, so the last value, the last thing that we need to cover today is about seaborne plots. So seaborne, if you see what is the basic difference between matplotlib and seaborne library, let me show you that basic difference between matplotlib and that library. I'm showing you this through my presentation. So I have chalked out some points of differences for you. Points of differences between matplotlib and seaborne. So basically matplotlib is used for basic graph plotting, like it could be line charts, bar graphs or something. And seaborne is used for statistic visualization that can perform complex visualizations. So the type of visualizations that I will be showing you now through seaborne will be more complicated ones. They would be more scientific. Now matplotlib was easy one. Okay, plotting a bar chart, pie chart and all those things is quite easy. But when you are plotting some complex graphs, then it is going to be something important. Matplotlib works with datasets and arrays, but Seaborn works with entire dataset. It does not require single column, but it can work on entire dataset. I'll show you in a while. Seaborn is considerably more organized and functional than Matplotlib, while Matplotlib acts productively with data arrays and data frame. It regards the aces and figures as objects. So basically, the main difference is that Seaborn can work in a more functional manner, it can work in a more organized manner because it can work with entire data set in one go. While if you work with Matplotlib, then in that case, it is working with a specific data frame, or you can say a reduced set of values, an array or a single column, a series of data you can work. Okay, Matplotlib, if you compare with Seaborn, Seaborn has more inbuilt themes and is mainly used for statistical analysis. If you work, Seaborn has inbuilt themes and it is used for statistical analysis as compared to Matplotlib. While Matplotlib is more customizable with pairs as well with pandas and NumPy for EDA. So if you want to go for just basic EDA, at the beginning of this session, I told you that we are going to do EDA. So if you want to do basic exploration on your data, you can work with Matplotlib. If you want to work with more scientific values, then you must go for Seaborn. Okay. So without wasting any further time, I just move to Seaborn. Now, how you can work with Seaborn? Seaborn is already, all your current versions of Python. If you have been working with Python for this week with Anaconda Navigator, then your versions of Anaconda Navigator, they already have Seaborn, Matplotlib, NumPy, Pandas already pre-installed, okay, in your Anaconda Navigator and in your Jupyter Notebook also. So you do not actually need to install something. Even if you need, you can just use the command of conda. Okay, with Anaconda, you can say conda install and name of that library. You can say conda install NumPy, conda install Pandas, conda install Matplotlib, conda install Seaborn. So just two words, two are your lifesavers, that is conda and install. If you want to install some dependencies or some updates in any library, you can just use conda install. Okay. Anyways, so I am importing here Seaborn as SNS. So import Seaborn as SNS. SNS.set. It will actually set your graphs according to Seaborn now, because I already have two libraries now here. I have Seaborn and Matplotlib. So here what I'm trying to do, I'm trying to set all my graphs now onwards with the help of Seaborn. Okay. But remember guys, one thing is important to remember, Seaborn works in conjunction to Matplotlib. So whenever you are actually plotting with Seaborn, make sure you import Matplotlib library also, because ultimate output showing or ultimate visualization is going to be worked with the help of Matplotlib. So it is always used in conjunction with Seaborn. Okay. So Seaborn, now you want to plot histogram in Seaborn, you can directly do that through the function distplot. So in Matplotlib, we have hist function. In Seaborn, we have distplot. The name is distplot. Okay. So this is distribution plot, you can say. Now it plots a combination. This distribution plot, first of all, see the output. You can see this is a bell-shaped curve. This bell-shaped, or the outline, is also provided in histograms with Seaborn. So Seaborn actually gives you a more appealing histogram where you can see the shape of the curve also. Why now you would ask me why shape of the curve is necessary? Like, see guys, when we are exploring our data, we need to see the biasness of our data also. We want to see whether our data is evenly distributed or it is skewed. Okay, the skewness is also easily visible when we have boundaries, when we have that outline available to us. Now this is a good bell-shaped curve. You can say this is not skewed, but if it would have been right skewed or left skewed, then this bell would have been tilted in it has been skewed. It may would have been skewed either to the left or right. So this outline gives you a good idea of skewness. So this data is not at all skewed. It's a good bell-shaped curve that you can see. So we can say this is unbiased data. This is non-skewed data. This is totally well-balanced histogram that we have plotted over here. Okay. This is not skewed. So how to plot it? You have to just use SNS. I have imported Seaborn as SNS. So SNS dot distribution plot function. Just put the column DF overall. That overall column we had used earlier. So in bar plot we had to do a lot of manipulations, but here when you are plotting histogram, the number of bins are quite easily visible. You can see this very important insight, that no player is having the you can say rating of 70. So either they have more less than 70 or more than 70, but not exactly 70. This is empty. So good insights can be, complicated, and good insights can be brought about by using Seaborn's histograms. Okay, so this is how it can be done. Now you can also plot good scatter plots over here. So I'm just going quickly how to create a scatter plot in Seaborn. So you have to use SNS dot scatter plot. Now you can use again overall and wages that we were doing earlier through Matplotlib. Now we are doing it through Seaborn. Overall versus wage. So you can just see again a better scatter plot. You can see, just compare it with the earlier scatter plot that we had done. If you see that earlier scatter plot, here you can see slow clumsy scatter. The scatter was very clumsy. It was clustered. It was the points are not at all visible. They are just, you can see a cluster of points, not very separable. The outlines are not very sharp. The graph is not very finely tuned graph. But if we are using the scatter plot, I am using the same data, everything same with scatter plot, you can see you can see a better tuning of the graph. Okay, that is so because Seaborn has the tendency to fine tune your graphs. Okay, you cannot see clusters, you can see individual points, and you can see again a positive correlation present between wages and the overall rating of that player. Okay, so this was the scatter plot that was with the function scatter plot. Matplotlib has the function scatter and it has scatter plot. Okay, just remember the differences. Okay, next, let us now go to some scientific graphs. Okay, so whenever you are going to work with machine learning, I hope you in these previous 3 days you would have seen, when you were working with machine learning, you would have seen how to create heat maps, how to see the correlations, because these explorations work. So this will be a simple, glance for you. So heat map is using for seeing correlations between different values. So I am now using 4 variables. I'm using overall rating, age, I'm using wages, and I'm using skill moves. Okay, just to see uh, that this particular correlation is created, how values are correlated to each other, which are the values that are more correlated, which are the values that are least correlated. So heat map shows you with the help of color intensity the strength of the values. The more intensified it is, you can see the color intensity is going from dark to less. So the more correlated it is, the lesser the value of color it is. You can revert the color scheme also. Anyways, you can make changes in your color schemes and in your ways that you are creating. So that is all okay. So simple heat map I'm showing you. So I'm creating a variable, say correlation, which will store a part of the data frame. So I will be working with a data frames part. So I'm storing overall column, age column, wage column, and skill moves column. So I have separated out these 4 columns from the data frame. I'm calculating the correlation through CORR function, which is a numeric function, a mathematical function that will create the correlation coefficients using normal Pearson's correlation or Spearman correlation. I'm not specified anything, so it will just do Pearson's correlation. Right? Pearson correlation, it will calculate it among all these 4 columns. Now I want to plot this correlation value in a heat map. So I can use Seaborn library sns.heatmap function, direct map heat map, and here I am giving the values of correlation, the correlation values that have been stored in this correlation variable. I am storing that, and annotation I'm putting it to true. This variable annote equals to true is very important, because if you want to see the correlation values inside the heat map, you can see the output, then 0.45 is present in this block, it is written 0.57 is written in this block. So if you want to see the actual plotted values, then you should do annote equals to true. PLT dot title, you can see heat map of overall age, wage, euro, skill moves, everything you can see. PLT dot show. So you are ultimately seeing that complete heat map. So this heat map is created. You can see the rows and columns. There are 4 rows and 4 columns because we had 4 columns that we were creating correlations of. So overall, so you can see overall correlation with skill moves is 0.41. So this is, quite a high correlation because it is intensified. Now you can see 0.028, very, very less correlation. Age and skill moves is very less correlation. You cannot say that with age, the correlation as age is increasing, the skill is also increasing, or there's a high relation between these two values. So this is low. Okay. Now, similarly, 1, 1, if you see this diagonal values, these are 1, 1, that means the values correlation with itself is always 1. So highly correlated self correlation, you can say overall correlated to overall by 1, age correlated to age by 1, and so on. So if you want to see higher correlations, you can see the higher correlations is between wage. As the number of wages increase, the overall rating also increase, which we have seen with the scatter plot. The above scatter plot was also showing a positive correlation, but a slow one because it is just 0.57. So it is the highest correlation should be 1. The more you are near to 1, the more correlated are values. So the values between wage and overall is 0.57. So we can say there is positive correlation, but a slow one. So that was once seen through scatter plot and proved, hence proved, you can see through heat map. Okay, so this is a positive correlation 0.57. Again, you have a good correlation between age and overall rating also, because with age and experience, the overall rating is also increasing. Okay, so this ways you can find the correlations. Okay, this is a symmetric plot. You can just see, you can is the same values what I was seeing over here. Overall with wage can seen with overall with wage here also. So it is a symmetric. Below and above diagonal, you can see symmetric. This matrix is showing you, it is a symmetric matrix which is showing you above and below diagonal the same type of values, the same number of values. Okay, so this is going to be a good thing for you to understand. Fine. So this is through you can say heat map we have seen. Now, next thing we have pair plots. Okay, this is again a very, very good scientific plot that you plot. The people who have worked in, different tools like Veka. If you would have worked in Veka, then in Veka pair plots are easily visible. If you would have worked in Power BI, then also the pair plots are quite easily visible. Through coding, you can also create pair plots, and through coding, you can do them either through Plotly library or you can do it through Seaborn library. Plotly and Seaborn are somewhat similar. They give almost good quality graphs. Plotly has, a slightly more advanced graphs, I can say. Seaborn also has a good rich set of graphs. So both are same. You can use any of them. Anyways, let us see pair plots. So pair plots help you to see pair of plots. Pair of plot means two combination of plots like scatter plot and histogram together. If you want to see the distribution also and you want to see how the values are distributed with some other function, with some other variable, then you can see them together through the scatter plot. So it gives you a combination of plots. Just see here. Suppose we want to see a distribution between overall rating, age and potential. I want to see a complete pair plotting of all three of them. Then how I can create a matrix. You can see first of all this output. Just see the output and then I'll show you the code. So this pair plot is being created. So you can see this matrix. So overall rating is being created with overall rating itself, with age column and with potential column. So when overall is graphed or plotted with overall column, because single column is there, so it is creating a distribution histogram. When it is being plotted with reference to age, you can see the first row overall being plotted with age. So you can see a scatter, means overall ratings are scattered with age. And when overall rating is plotted with potential, then you can see a slightly moving up, or you can see a positively correlated scatter plot that is moving up. Okay. Now, similar to that, when age is correlated with overall, then this is a scattered graph that you can see. When age is correlated with age itself, you can see a distribution histogram. When age is plotted with potential, again, you can see a very, very clustered and scattered. So no correlation can be defined. So you can say no specific correlations can be defined with age and overall, because age and overall both are plotting, a good scattered graphs. These are, null correlation, I would say, no exact correlation. And that is what you can also infer from this heat map, that age and overall correlation was 0.45, which was not a very good correlation, not very positive. So it was, a very so-so correlation. Okay. So there is no good trend that could be seen over here. So similarly, potential when plotted with overall, it is giving you a good graph, which is slightly increasing. Potential with age, again, very scattered, not very good. And potential with potential gives you a good, you can say, histogram. So if you see this particular histogram, this was skewed one, which I was telling you earlier, because the bell shape that you will get here will be probably left skewed. So the, left side values are higher as compared to this. Okay, so ages means more younger players we have as compared to older players, so more younger players. So it is left skewed with reference to age. So you can infer that more number of young players are there because of the left skewness of age. So I'm just trying to give you more insights on how you can infer from the graphs. Okay. And this potential is a well balanced graph. It is not skewed. So it is neither bimodal. It is not skewed also. So it's a well balanced. It is a, you can say, a well shaped curve, a good bell shaped curve you can get over here. Okay. So this was about, Seaborn and how you can create graphs. Okay, next I have some more thing for you. I think we have some more time left with us. Yes, we can continue for some more time. We can completely do this task. So guys, we have one more chart. We have line chart available with us. Now this, earlier all the charts we have done on FIFA 19 Football World Cup. Now I am doing it for another data set. I have taken another data set now, line chart, for seeing the line chart. I am using Tesla company's stocks. Okay. The stocks data set, again, you can download it from GitHub. There are two repositories, guys, which I like. I myself like. There are so many data repositories. There are so many world data repositories that are freely available to you. But if you actually want to see, good data, then you can either refer to Kaggle, or you can refer world datasets. The name is world dataset only. The website is world datasets, or you can refer to GitHub, because GitHub also has good datasets. Okay. So this I have taken from GitHub. This is Tesla stocks. I will give you the link for this dataset. Okay. From where you can download this Tesla stocks dataset. So this, let me just show you, if I can show you this dataset. Yes, I have this datasets available. So this is the Tesla stock dataset. So this dataset has the stock values right from 2015 year to 2016, 17 and 18. So you can see this Tesla stocks, Tesla company stocks. I have the values from the year 2015, 16, 17, 18. So these 4 years I have the data, and the data consists of the date, the closing value, the volume of the total volume of the stocks that was exchanged, the opening values, okay, of the stocks, the high value that the stocks that went on that day, and the low value of the stock that went on that day. Okay, so we have that stock market data with us. Now you will be surprising, or you will be thinking that why I'm taking this stock, surprisingly I'm taking the stock market data. That is so because our data chart is line chart. Okay. Line charts are basically worked upon when you want to see a time series data. When you want to plot some, trends, you want to see some trends. First, let me show you the output. Then you will get to know how I am doing it and why I'm doing it. So just see the output of the line chart. You would be able to see this. This is a trend. Okay. Trend of charts. If some of you are very active on stock markets or bitcoins or all these data, all these sites where you can buy or sell bitcoins or buy or sell stocks, then for every stock you have this kind of chart. I hope you would have seen, or if you have not seen, you can visit some stock market data sites, and there you can see these kind of line charts being drawn. So this is a real time data that I've taken for Tesla stock market, Tesla stocks, and I will be plotting the trend, or I will be plotting the time series data for Tesla stocks on your screens. Okay, so the data set I've already shown to you. So I have imported that data in stocks data. So I'm plotting this time series, and I'm trying to connect it with straight line. So basically guys, it is a line chart, as the name says. Assumably we see, straight lines plotting, but really when the data is there on the real time basis, never ever you are going to see the straight lines. Okay, because sometimes it will be low value, sometimes it will be high in value. So you can see the every time you can see dates also there. So I'm plotting it date wise. So you can see on each and every date, sometimes it was low in the range of value, sometimes it was high. So it is never ever going to be all the same, or never going to be symmetrically upwards in a straight line. So the slope of the line is never ever going to be one. Okay, so the slope of line is never ever going to be symmetrical. So remember that particular thing. Anyways, let us go how to go about this line chart. So I have just taken that data frame in stocks data. So stocks data is a new data frame that I'm creating. Pandas, I'm using pd.read csv. So I have saved that Tesla stocks csv file in my folder, dataset folder. I'm taking it from there, and I'm seeing the first five head method, as you already may be knowing, that it shows you the first five rows of the data. So you can see the first five rows of your data. Okay, you have date column, you have close, volume, open, high, and low. Now, I want to plot this time series. I want to plot, suppose say I am trying to plot this high column. Okay, I want to plot how high the values go per day. I want to see some trend out of it. So for plotting that time series, I need to have one column specifically which had to be time or the dates, and another column is the data that you want to plot, because the name suggests time series. So time series means one axis should be specifically time axis, and that is always and always going to be x-axis. Always remember, whenever you are going to plot time series, it is always going to be x-axis, and whenever you are going for another data, the other variable is always going to be y-axis. So here the high values of the stocks are definitely going to be on the y-axis, and the x-axis values is definitely going to be date values. Now guys, in my data set, if you once again see the data, okay, here only in the data frame, if you see, this data is in the form of strings. Let me show you. In the data set, you can see Tesla stocks. This is in the form of strings. So I need to, convert it into pandas time data. Okay, I want to convert it into pandas time. So how I can do that? I need to first of all convert this date into pandas date time data type. So it is easy to do. You can just say stock underscore data date. I'm just in place of that data frame. This is the data frame. In this place of data frame, I'm modifying this date column. I'm just trying to modify this date column in place. Okay, so stock data date column equals to pandas. I'm converting it into 2 underscore date time. So I'm converting the already given this string date. Okay, stock data date, I'm converting it into date time using pandas and storing it in the same place. I'm storing it in this data frame only in the date column. Okay, so now if I try to print the data frame, you will get this particular thing. So now it is not this, it is not in the string format. It is in the format of the date format of your panda. So which is hyphen format. Okay. So year, then your month, and then the date. Okay. So the formatting of pandas is now used. It will be easy for me now because I have exact dates. I have the high value. So it will be easy for me now to plot the things. Okay. So simply how to plot it, you can just specify the figure size. Figure equals to plot dot figure size is 10, 6. Now x is 1. So I am ax1. I'm just trying to plot the x's. So ax1 equals to figure 1 dot add x's 0, 0, 1, 1. That means it is going from 0, 0. It should begin with, the center point is going to be 0, 0. And for x-axis and for y-axis, it is going to be 1, 1. 1, 1 means the maximum limit that you can plot. Okay, the maximum values in your data that you can plot. Title, I am plotting Tesla stocks, high stock prices. AX1, axis, the first axis that I am plotting axis1 dot plot. stock data date. So x-axis, first of all, I'm plotting the x-axis dates that I'm plotting over here on x-axis. Then stock data high values. This is the y-axis that will be plotted. Okay, so y-axis which will be plotted with the high values of the stocks. Then color of that line. Okay, the line plot of that, the color would be green. You can plot anything, red, blue, anything that you want. I have plotted it for green. Now I am doing it X ticks rotation 90. That is so because I want to see these dates without being smudged, without being superimposed by other dates. Okay. So that is why I have rotated them, shifted them by 90 degrees. So plot dot show. So as soon as you plot it, x-axis value, again, just see I'm plotting it. I'm just putting ax1 dot plot. So I'm plotting it for, first of all, x-axis on date. Then I'm plotting it for y-axis on high. Then I'm giving the color as green and I'm giving the rotation as 90. So as soon as you run this code, you are going to get the trend values. This is a time series plot that you can see. So the trend, if you plot the trend line, if you just put a dot value passing through all these graph, this line graph, then you can see a higher trend. So this trend you can say is increasing. Okay, so this is a big line graph. So maybe on my screen, you may not be getting the entire thing at one place, but you can see again the trend is increasing. So it is increasing, decreasing now. At this moment at 2018, it is somewhat decreasing, but it is the probability that it may increase in some time future. So the trend is on the increasing track. Fine. So I hope you now know how to plot stock prices also. Okay, this way you can plot anything. Fine. Okay, the last and the final graph of the day from my side is the box plot, because the discussion on visualization is incomplete without the discussion of box plots, because these are some of the plots which are used for outlier detection. Okay, uh, I wanted to show you something on the real-time bank fraud detection data, but that data needed a lot of cleaning and everything. So for this limited time frame, I am showing you on a limited data set. Okay, that is cleaned. Okay, so I'm showing it on a clean data set. So this data set would be, a restaurant data set on that is having some, tips. Okay, the data set which is recording the tip calculated by the restaurant every time. And we want to see how many male customers are giving the tips, female customers are giving the tips on daily basis, and what are the outlier days also. Okay, because at some days when there's some big party or some big, rich clients are there in that restaurant bar, then maybe your bar is getting more tip. Okay, so I want to just analyze that data set, and I want to see the outlier through box plot. So box plot is a visual representation which actually depicts group of numerical data through their quartiles. Now when I say quartile, okay, then quartile means 25%, quarter of that value. So if total value is 100%, then your complete data will be divided into set of 25%. So there are four quartiles all in all in your box plot. So box plot is used to detect data outliers also. So I will not read the entire thing. I will show you something. Okay, I already have inbuilt image with me. So I'm showing you that image. So this is a box plot image that you can see over here. So with this image can show you that entire data is divided into four categories, four quartiles. This plot is more preferably known as box and whisker plot. So this rectangle that you can see is the box, and these two lines below and above are the whiskers that we have. Okay, so if you see beyond this, we have some dots. Above that, we have some dots. These are outliers. So our entire data is in this box and whisker, and after this box and whisker range, we have this outlier. So whatever data we have beyond the limits, it is the outlier data. Okay, so you can see these two whiskers. These are the having the minimum value. This whisker is on the lower limit, so this is having the least value, and this whisker on the above side is the highest values, greatest values that your data can have, excluding outliers. So this, if you see the median line, this median line is the 50% quartile or the 50% data. So the median values of your data, 50% of data is in this line. So this whisker is plotting 50% of the data, and after this median line, Again, next 50% of the data will be plotted. Okay, this lower limit is the lower quartile, 25% of the data that is less than the value that assumption value, and upper quartile is the 25% of the data greater than the assumed value. Okay, so if you are seeing a particular value, then box plot can be plotted for that particular values. Okay, I'll show you how we are creating that. So you can see outlier less than 3 by 2 times means 75% of the data. The lower outlier is in the lower quartile. Okay, and outlier which is above you can say 75% of the data, it is known as upper outliers. Okay, anyways, you can see the details, you can read the details in the, you know, from some sources, you can read the details. I will show you how to plot this box plot. Okay, now, if you want to plot this box plot on the tips dataset, let me first of all show you the tips dataset. It will help you to understand that dataset also. So this is the tips data set. So this is the total bill. This is from a restaurant pub, restaurant bar. Okay. So this is the total bill that will be generated in terms of dollars. Then the tip that is being generated from this total bill, $1, $1.66, $3.5, and so on. Then this tip is being given by female, male, sex. This is the tip. Tip is being given, and the sex of the customer could be male, female. Okay, then smoker, whether that person was a smoker, no, or yes, whatever it could be. Day could be, weekends. We are seeing on the weekends the tips are being more. So we are calculating this for Saturdays and Sundays and Thursdays, Fridays. Okay, so we are having this kind of data. So we have some data from Thursday, Friday, Saturday, or Sunday. Then time of that particular tip, it may be in the dinner time or maybe in the lunch time. Then size. Okay, the size of that particular group that was having dinner, or it was a a couple was having dinner, or friends of 4, friends of 2, people 3. So you can see the size of the client, the size of the customers was there. So number of people that were having that dinner was 2, and the tip or the payment was given by that female customer, or the size of that group was 3, and the payment was given by that male customer. Okay, that is why it is showing you male, because the tip was also included in that payment. Right? So I hope you would have understand the data, and we want to plot this data through the help of a box plot. Let us see how we can do that. So I am loading the data set td.read_csv. So I have loaded this tips data set. Now you have to see that data. So through data frame df2, the data frame is you can see the first 5 rows. So through head values, you can see these rows. And finally, you are generating the box plot of days with respect to total bill. So you are trying to plot the box plot. So just we are trying to plot the vertical box plot. How we can do that? Cbond.set style white grid. So we have plotted the set style white grid. You can see background is white now, so as to highlight the boxes. And then we are saying SNS.boxplot. We are plotting the box plot. The x-axis is having day, so you can see x equals to day, because this day we are plotting Saturday, Sunday, Thursday, Friday. Y-axis should be having the total bill, so you can see total bill over here plotted on the y-axis. And data, that data in the box plot should be taken from this entire data frame. So as I told you, the entire data frame df2 can be used, so I'm using this entire data frame df2. So as soon as you do it, as soon as you go about it, you can see this complete box plot being plotted over here. So this box plot, there are 4 specific plots being done for Thursdays, Fridays, Saturdays, and Sundays. So you can see what insights you can draw. Let us see for one complete plot. So suppose say for this blue box, we have to get some insights. So from this blue blocks, what can be the insights? The bottom black horizontal line of the blue blocks, blue plot is the minimum value. So this is the minimum value. It is somewhat between 15 to $20, because it is more than half of this 10 and 20. So I'm just saying this 15 to $20, in the range of that you have approximately this minimum you can say bill. So on Sundays the minimum bills was this. Okay, The first black horizontal line rectangular shaped box is the first quartile. So you can see this is the first quartile it is showing you. Okay, this is the minimum. Minimum value is beyond $10. This is the first quartile, approximately $15. Then 20 is the median value. So you can see second black line is the second quartile, which is nothing but minimum values you can have. So this is 50% or 50% quartile. Okay, then the third black line here, you can see it is between 20 to $30. So, above 50%, 75% customers were in the range of $25 to $30. And lastly, the top black line shows you the maximum value. So the maximum bill that was generated that day was $40 approximately. Now, the small diamond shape of blue box is the outlier data or erroneous data. So this can be some outlier or erroneous, or something which is not compatible with your data set. So you can see these two diamond shaped points will become the outliers. Okay. So guys, this way you can get insights for the orange boxes also, that the minimum value on Saturday was something, in the range of $2 or $3, and the maximum was just $40. And similarly, first quartile, first 25% data was around $15 or something. Median was less than 20, and the above average value was also less than 25. Okay, and the whisker, the maximum was increased to $40, and these three are the outliers. Okay, so three records we have which are something erroneous or outlier data. Or you may have some data which actually did not pay. It was somebody who ate and escaped, or it was some data which was out of the box, or you can say something which was some kind of erroneous, or some kind of thing which should be investigated more. Okay, outliers. Okay, so this way, guys, we can visualize our data. We have seen, all in all, we have seen three data sets: FIFA for Football World Cup data set, Tesla stocks data set, and Resto Bar tips data set, where they wanted to see, analyze if some errors are occurring in their payments, or if some frauds are occurring while payments, or something is happening in outlier data. So with this, we come to the end of data visualization through Python by using Matplotlib and Seaborn. Just one liner before I end, that data analytics is a very, very vastly growing field. It has lots and lots of technologies and tools available. If you are through with the coding, if you know coding in a good way, you can go with the code and create all these graphs and visualize data through graphs. If you do not have a good hands-on on code and you want to use some tools, then you have good tools like Tableau, Power BI, Quick. Okay, all these are good tools that are nowadays used for business intelligence plotting. So you can go for visualizations through those tools also. Okay, so with this, I hope you would have enjoyed having this session of hard code with me. You would have understood the things that I wanted to explain to you. So it was a good, nice experience for me, and I hope the same for all of you. Thank you so very much for being so patient listeners, and so being so good listeners. If anybody has any doubt, we can come over that. I hand over now to Sonia ma'am. Sonia ma'am, can you hear me?
Yeah, Nidhi ma'am.
Yes,
Thank
ma'am.
you so much.
Thank you, ma'am.
Thank you for sparing another valuable day for us.
Thank you, ma'am. It was my pleasure.
Very
Thank you.
informative session. Yes, learned so many things. And yes, truly, analytics, another very booming area, we all know.
Yes.
So, everyone, I hope, would be very happy to attend these sessions. And yes, intellectually, we have learned so many things. Thank you so much, ma'am. Thank you for the session.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. My pleasure, ma'am.
Thank you, ma'am. Thank you, all the participants. We'll join you back at 2 o'clock with the valedictory session and a quiz. The quiz is compulsory for all to be attended. There would be 20 questions and 20 minutes for it, and the score would be required for providing the e-certificates. Thank you so much, everyone. Meet you all at 2 o'clock.